Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of carrier sense, multiple assays and its type. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of CSMA-CD. The CSMA-CD stands for Carrier Sense Multiple Assays with Collision Detection. That means here CD stands for the collision detection. It defines how network devices respond when two devices attempt to use the data channel simultaneously and encounter a data collision. The CSMACD rules defines how long the device should wait if the collision occurs. Okay, that means the CSMACD network is used when the two devices or the two stations, suppose station A and station B, finds the data collision between them. Okay, then the CSMACD defines how long the device should wait for the collision. Okay, the problem with CSMA is that the transmitting station continues to transmit its frame even though the collision occurs. The channel time is unnecessarily wasted due to this. We seen that in CSMA, if the two channels, suppose channel A and sub channel B, transmit the same on the idle channel, then if the collision occurs, even after the collision occurs, the station A transmits its data and station B also transmit its data. That means the station A and B continues transmit its data. Due to this, the channel time is wasted. Okay. Hence, in CSMACD, if the station receives other transmission when it is transmitting, then a collision can be detected. As soon as it occurs, the transmission time is saved. How this time is saved? Let's see. As soon as the collision is detected, the transmitting stations releases a jam signal. The jam signal will alert the other stations. The stations then are not supposed to transmit immediately after the collision has occurred. Otherwise, there is a possibility that the same frames would be collide again. After some back of delay time, the station will retry the transmission. If again the collision takes place, then the back of time is increased progressively. That means in CSMACD, if the channel, suppose A, channel B, suppose channel C, want to transmit the data, then they checks the status of the channel. Okay, if A senses this channel is idle, then A transmits the data. That means A transmits the data frame, and if A transmit the data frame towards B, and if the A does not completed its transmission at the same time, B founds the channel is idle, and then at the same time B transmits its data towards A. Okay, and if in this case the data collision is occur here, as soon as the collision occurs, then the station releases the jam signal. After jam signal, the station A knows that the other station also want to transmit data. Similarly, station B knows that the other station also want to transmit the data. In this case, both the station A and station B aborts the transmission or stops the transmission. This is happening in the collision detection type, CSMA. Let's see, this is the figure in which the station A and C are involved in the collision. Okay, let's see the description of this figure. At time t1, the station A has executed its persistent procedure and starts sending the bits of its frame. That means the station A has the data and it want to transmit it through the channel. The station senses the channel, and if the channel is idle, then at time t1 it transmits its data. Okay, at time t2, the station C has not yet sensed the first bit sent by A. That means at time t1, the station A transmits its data, but at time t2, here this data is not occurred or it not senses the first bit of A. That means, okay, station C executes its persistent procedure and starts sending the bits in its frame, which propagates both left and to the right. Okay, that means this transmission is not occurred at C, hence C finds the channel idle and C transmits the data towards left and towards the right. The collision occurs sometime after time t2 station. C detects a collision at time t3 when it receives the first bit of A frame. The station C immediately or after short time, but we assume immediately aborts the transmission. That means here at time t3, the station C senses the first bit of A. Let's see once again. At t1, A transmits the data. At t2, C does not sense the first bit of A. Hence, C also transmits the data. But at t3, C senses the first bit of A. Hence, the C finds the detection here and it aborts its transmission. Okay. Station A detects the collision at time t4. That means the station A detects here at time t4. That means it transmits data. Here it station A detects the collision. It receives the first bit of C's frame. It also immediately aborts the transmission. Looking at the figure, we can say that A transmit for the duration t1 to t4. A transmit the duration for T1 to T4 and C transmit for the duration T3 to T2. The protocol to work the length of any frame divided by the bit rate. This protocol must be more than either of these duration. At time t4, the transmission of A's frame though is incomplete, hence it is aborted. At time t3, the transmission of C's frame though incomplete, it is aborted. That means in both the cases, both the transmission through A and transmission through C is aborted. Okay, I hope you all understand the diagram here. Now here we comes at the important idea, minimum frame size. For CSMACD to work, we need a restriction on the frame size. Before sending the last bit of the frame, the sending station must detect a collision, if any, and abort the transmission. This is so because the station, once entire frame is sent, does not keep a copy of the frame and does not monitor the line for collision detection. Therefore, the frame transmission time TFR must be at least 2 times the maximum propagation time TP. That means TP should be greater than or equal to twice of FR. Okay. Now let's see the flow chart for CSMACD. This is the flow chart for CSMACD, in which we can see here that various processes are done and various symbols are used. Here K is used for the number of attempts. The TP is maximum propagation time, TFR is average transmission time for a frame, and TB is the backoff time. Let's see details about the flowchart one by one. The station that has a ready frame sets the backoff time parameters to 0. That means the station has frame to send, it sets the parameter K is equal to 0. Then it senses the line using one of the persistent strategies. Then the station which want to transmit data, it senses the line or the channel using the persistent strategies. Okay, and it then sends the frame. It then sends the frame if the channel is idle. Okay. If there is no collision for a period corresponding to one complete frame, then the transmission is successful. That means it senses the channel, and if there is no collision, the transmission is successful. Otherwise, the station sends the jamming signal to inform other station about the collision. Okay, here we send, or the station send, the jamming signal when the collision is detected. Then after some back of time, which is given by the formula k is equal to k plus 1, the station increments the back of time and waits for the random back of time and sends the frame again. Okay, after this backup strategy, the station again goes to first step and it sends the frame again. The backup time has reached its limit, then the station aborts the transmission. That means here, if the backup time or the backup strategy is reached at the limit, which is 15 in this case, then it aborts the transmission. Okay, I hope you all understand the flowchart of this protocol. The application of CSMACD is that the CSMACD is used for the traditional Ethernet. I hope you all understand the CSMACD protocol. Thank you.